Okay, so we're on section 12.1. This is the last thing we're going to talk about. You're almost done with geometry. Just a few more days. Okay, so, but I wanted to do this one. Now, this is something, if you took Algebra 2 here, I know you had this stuff in Algebra 2 because I taught it to my Algebra 2 here this year. So I know it's in the Algebra 2 curriculum if you had it here for sure. With your Trigonometric Ratios, but they usually just call them Trig Ratios instead of trigonometry, okay? It deals with our right triangles mainly. So remember, in a right triangle, you have the two legs or the two sides that make the right angle. So I have leg A and leg B here. And then you have the long side, which is opposite the right angle, which is the hypotenuse. And I reviewed that part with you yesterday. Now, what we are focusing on is we pick one particular vertex, one angle that we're going to focus on. So I'm focused right now on A. So here's angle A. So we have three main trig ratios. Now there's 6 total, but these are the 3 main ones, okay? Your sine, okay? Your cosine, and your tangent. Okay, so the sine, it looks like sin, but it's not sin, it's sine, okay, because the word it stands for actually has an E on the end. So sine of A is the side opposite over this hypotenuse. Remember, they're called trigonometric ratios. Ratios are usually written as fractions, okay? So you take the side that's opposite angle A, which is over here, that's my opposite leg, over the hypotenuse. For cosine, you use the leg adjacent. Adjacent, remember, means next to, over the hypotenuse. And then for the tangent, it uses the side opposite over the side adjacent to the angle. Okay, so we have 3 main ratios that we use. Most of what you're doing on these today is just writing that ratio. Now, sometimes it'll ask for it in the decimal form, so that's when the little calculator comes in handy because you'll have to divide your fraction. You get big, long decimal, you round it off to whatever place they tell you to, okay? But the main focus of what we're going to be doing is just being able to look at the triangle and identify the sine ratio, the cosine ratio, and the tangent ratio, okay? So that's where we're starting. On page 579. You'll notice that it says we're going to do 2 through 12 even. So 2, 4, 6, 8, 10, 12, and then we're going to talk about 13 and 14. Which 13 and 14, you definitely, all you got to do is use a calculator. So we'll be good with those. Now, for 2, 4, and 6, you have these triangles here in the book, and you'll notice all of the sides of each triangle are labeled. And it just says, state the exact value of each trigonometric ratio for the given angle in the right triangle. When it says exact value, that means you're going to have it as a fraction. Okay? Exact value is the fraction, because most of the time, if you do it as a decimal, it's not an exact value. It ends up being a decimal that goes on forever, and you have to round it off. So that's why that's not the exact value. Leaving it as the fraction is the exact value. Okay, so that's where we're at. Okay. So on number 2, it says for the sine, cosine, and tangent of B. So you have to look at your triangle, okay? On my triangle, your triangle for that one is shaped this way. This is A, this is B, this is C. C is the right angle. This is 3, this is 4, this is 5. So all you do is on this one, you're using B as your vertex. Okay, so here's B. So the 4 is opposite of B. The 3 is adjacent to angle B. And the 5 is always the hypotenuse, the one across from the right angle. So if I want the sine of B, I'll just write that fraction. Opposite over hypotenuse. So the opposite was 4, the hypotenuse was 5, and that's it. So that's my sine of B. My cosine of B is the adjacent side over the hypotenuse. So my adjacent side was 3, and my hypotenuse was 5, so it's 3 over 5. You're just writing the ratios, okay? So all we're doing is writing the ratios. For tangent of B, tangent says opposite over adjacent. So the side opposite was the 4, the side adjacent was the 3, so it's 4/3. And that's it. You look at the picture, you write the ratios. Okay, pretty easy. Okay, I was trying to give you something easy at the end. Now, our next triangle shaped the same way. Okay, this is D, this is E, this is F, this is 5, this is 6. Yes, and this and the square root of 61, right? All right, so we're still doing the same thing. We're doing our sine, our cosine, and our tangent. So sine, opposite over hypotenuse. So the side opposite of angle E, here's E. So this is my opposite, this is my adjacent, this is my hypotenuse. So opposite over hypotenuse. So 6 over square root of 61. Now we're going to have to come back and talk about that a little bit more in a minute, but right now let's just get them written. Okay, cosine of E. Cosine is adjacent over hypotenuse, so it's 5 over square root of 61. And then our tangent is opposite over adjacent, so it's 6 over 5. So that one was easy, okay? We have 6 over 5. These two, we got to do a little bit more work. Because the thing is in math, they do not like a square root in the bottom of a fraction, okay? It's a no-no to leave it that way, okay? We are not supposed to do it. So since we're not supposed to leave it in the denominator, to get rid of a square root, you multiply it by itself. Because the square root times the square root gives you the radicand, the number underneath, without the square root sign. Okay, so that's what we're going to do. So looking at this here, we're going to multiply by square root of 61 over square root of 61. So 6 times square root of 61 is 6 square root of 61. And then in the bottom, any square root times itself is just the number without the square root sign. So it's still pretty easy. You just have to multiply by the square root over itself, because that's 1. If you multiply by 1, does it change the value? No, it's equal to the same thing. So that's it. So on this one, I still got to multiply by square root of 61 over square root of 61. And I get 5 square root of 61 over 61. So my sine ended up being 6 square root of 61 over 61. My cosine of E ended up being 5 square root of 61 over 61. And then my tangent of E was 6 over 5. Okay. Now, next one. For number 6, our triangles pointed the opposite direction. Okay, for number 6, our triangle is going the opposite direction. Okay, so I'm going to put it over here. I'll move the camera over in a second. It has 4, oops, this is Y, this is Z, this is X. And we got 2 square root of 13. All right, that's 6. All right. Scoot you over a little bit so you can see the triangle. All right, so on this one, this is your triangle. You got it there in your book. But remember, we got to pay attention to what's opposite, adjacent, and hypotenuse. Okay, we're talking about angle X this time. So here's angle X, that's my focal point. So the side opposite is the 4. The side adjacent is the 6, and then the 2 square root of 13 is our hypotenuse. Okay, so we're going to have to kind of do like what we did on number 4. We're not allowed to leave that square root in the denominator. Okay, Pedro, you know where we're at? Okay, so sine of x says opposite over hypotenuse. So 4 over 2 square root of 13. 4 over 2 square root of 13. Now, first things first, I see 4 over 2. Can I go ahead and simplify that?
Yeah.
Yes. 2 goes into 4 2 times. So basically, I got 2 over square root of 13. But like we talked about here, I'm not allowed to leave a square root in the denominator. So I have to multiply by square root of 13 over square root of 13. So up here, I have 2 square root of 13 over 13. So that is my sine function. Now, cosine is going to be similar. Cosine is the adjacent side over the hypotenuse. The adjacent side to x is the 6. And then the hypotenuse is still 2 square root of 13. Again, I can cancel 2 goes into 6 3 times. Then I have to multiply by the radical over itself because we never want to leave a radical in the denominator. So I have 3 times square root of 13 over 13. And then your last one, your tangent. Tangent is opposite over adjacent. So 4 over 6, which I can reduce both of those by 2 and get 2/3. So for number 6, you have 2 square root of 13 over 13 is your sine of x. Your cosine of x is 3 square root of 13 over 13, and your tangent of x is 2/3. Okay? Now, for number 8, 9, and 10, the directions are a little bit different. For number 8, 9, and 10, it says state a decimal approximation to 4 decimal places, so 4 numbers behind the decimal point, of each trigonometric ratio. Now, something else that you should notice that is different on 8, 10, and 12 is do they have all 3 sides of the triangle already labeled?
3 sides? No.
No, they don't. How do we find the missing side in a right triangle?
Pythagorean.
Pythagorean theorem. So on these, we're going to have to do our Pythagorean theorem, a squared plus b squared equals c squared, and find the missing side before we can do the ratios. Okay, so we're going to start on number 8. Okay, on number 8, we have the one side, we have the 2 legs in number 8, because it's this first triangle here. You've got the 2 legs, and you need to find the hypotenuse. So for number 8, you're going to have 16 squared plus 30 squared equals c squared. You're trying to find the hypotenuse. So you use your little calculator. Okay, we'll use our calculator. 16 squared is what?
1156. Oh, well, all of it together.
256.
Yeah. It's 256. 30 squared is 900. So you get 1156 equals c squared. Now the opposite of squaring something is taking the square root. So we take the square root. So square root of 1156 is equal to 34. Okay? So your triangle looks like this. This was 16, this was 30, and now this is 34 we found. Okay? So this is my triangle. We're looking for the sine, cosine, and tangent of B. B is up here at the top. So this is going to be my opposite. This is going to be my adjacent, and then the 34 we found is our hypotenuse. So now on these, we write our ratio, but then since it wants them as a decimal, we're going to go ahead and divide them out, okay? So sine of B is opposite over adjacent. So opposite over hypotenuse, 30 over 34. So all you do is you take 30 divided by 34, and you get it as a decimal, and it's this big long decimal that goes all the way across my calculator repeating. Now, it said you want 4 decimal places. So I look at the first 4 numbers, and I have 8, 8, 2, 3. Then the next number is a 5. Is that 5 going to make the 3 go up? Yeah. Yes. So it's 0.8824. Okay. Now, cosine of B is adjacent over hypotenuse. So it's 16 over 34. And you divide it. And then tangent of B is the opposite over the adjacent. So that's 30 over 16. And you divide it. So divide those and get your decimals. See if you round the same as I do. But those are what I got. Everybody agree with those? Okay. So we have to do the same thing on number 10 and on number 12. Now on number 10, again, we don't know the missing side of our right triangle. We have the leg on the bottom, and we have the hypotenuse, and we're looking for the little leg over here. So we're looking for the little h. So I'll have h squared plus 12 squared equals 13 squared. So I have to solve that first and find my missing side so I can put it on a triangle. So hopefully everybody knows 12 squared and 13 squared. And then this time I don't add them together because they're on opposite sides. I have to subtract because you're trying to get the h part by itself. So I have h squared equals, excuse me, 25. So the square root of h is 5. So on this one, your triangle looks like this. This is 5, this was 12, and your hypotenuse was 13. Now, for number 10, we're talking about, get y'all over again. For number 10, we're talking about our sine, cosine, and tangent of h. So h was down here at this bottom. Okay, so we're looking at h. So h is down here at the bottom. So 5 is our opposite, 12 is our adjacent, and 13 is our hypotenuse. So those are the numbers that we're going to use for our ratios. But remember, on these, we're having to divide and get them as decimals. So remember, for our sine, it's opposite over hypotenuse. So the side opposite of angle H was the 5, and the hypotenuse was 13. So then you just take 5 divided by 13. Ooh, I had something already on my calculator, so I got really weird answer. And you get your decimal. Now, you get a repeating decimal, but remember, we only want 4 decimal places. So you look at the first 4, and then is the 5th one going to change it?
Yep.
No, because 1 doesn't make 6 go up. So
Yep.
it's 0.3846. Okay. Next one is the cosine. Cosine is adjacent side over hypotenuse. So that's 12 over 13. So 12 divided by 13. Get another repeating decimal, 0.92, and then it's 307. So the 7's going to make the 0 go up to a 1. And then for the tangent of h, it's opposite over adjacent. So that's the 5 over the 12. Again, you get a repeating decimal. It's 416 repeating. Just the 6 repeats on the end. So it's 0.416. And then the last one's going to have to round up to a 7. Okay. Now, does anybody remember doing stuff like this in Algebra 2 with your sine, cosine, and tangent?
Very, very, very little.
Okay. But these ratios, I know that you should have had before, okay? I just wanted to remind you of them because you all are getting to the point, you know, before long, next year, whatever, you'll have to take ACT. You're planning on going to school, you know, your ACT. So these are always on there. So you don't have a lot of questions that have them on there, but your basic sine, cosine, and tangent are always on there. So you got to be familiar with them. That's why I want to make sure we still covered them again a little bit. Okay. Now for number 12, on that triangle, we have our triangle looks like this. Okay. It's taller. This is M and an O. This is a 2. This is a 4. So we're looking for this side right here. So we're looking for one of our legs. So we're going to have to do Pythagorean theorem again. So I have m squared. I'm going to call that m because it's across from the m vertex. M squared plus 2 squared equals 4 squared. So m squared plus 4 equals 16. Subtract 4 from each side. M squared equals 12. Take the square root. Now, square root of 12, 12 is not a perfect square. So it's not going to work out evenly. You get 2 square root of 3. This would have been one of our 30, 60, 90 triangles. Does that sound familiar? 30, 60, 90, you got short leg, long leg, hypotenuse. Okay, they have the ratio 1 square root of 3, 2. Okay, so I have on my sides now, I'm talking about vertex N. So from N, 2 is my opposite. 2 square root of 3 is my adjacent. And then 4 is, of course, the hypotenuse. Okay, so we write our ratios. Sine is the opposite over the hypotenuse. So opposite of N is 2 over the hypotenuse 4. Cosine is adjacent, 2 square root of 3 over the hypotenuse 4. And then tangent is opposite over adjacent, so 2 over 2 square root of 3. So now we just divide all those to get our decimal equivalents. So what do you get for this one? This one should be easy. You should be able to do that even without dividing it.
Calculator got 2.
No.
No?
0.5.
0.5.
Oh.
You got to put it in the calculator correctly to get the right answer. The number on the top is what goes in the calculator first. 2 divided by 4 is 0.5. Now your next one, you got 2 square root of 3. And if you've got a scientific calculator, you can type it in exactly like that. Divided by the 4. See? 2 square root of 3 divided by 4. You hit equal. It gives you a reduced fraction. Then hit the little SD. You get 0.8. 8660. And then the last one, what do you get for that one? Anybody dividing it?
Well, I don't know what I got.
Is it gonna round up? Look at the screen.
Oh, yeah.
Yeah. 5's gonna make the 3 go up, so it's gonna be 0.5774. Okay. Now, for 13 and 14, it says use a calculator to find a decimal approximation to 4 places of each trigonometric ratio. On these, instead of, it's given us the actual angle measure. And so the way we do that is if you've got a scientific calculator, you should notice that on there you have a sine button, a cosine button, and a tangent button. You have the buttons that will put them on the screen, sine, cosine, and tangent. So all you do is you push the correct button. So it says on 13, sine of 50. So I push the sine button, and I type in 50. You can close the parentheses if you want to, but you don't have to. So I got sine of 50 degrees, and then if I hit equal, it's going to give me the big long decimal. Now remember, it told us we wanted how many places? 4 places.
4.
So it's going to be 7660. And that's number 13. So you do the same basic concept on 14, except it was cosine. So I use the cosine button. Hit the cosine button, it puts it on the screen. Type in the angle measure, hit equal. Write down your answer, round it to 4 decimal places. Okay. Now, trigonometric ratios. Okay, can everybody tell me what 2 sides? I'm going to move so you can't see them. Okay, can you tell me what 2 sides you use for sine?
I wrote them down. Let me see. For sine?
Opposite and hypotenuse.
Opposite and hypotenuse. Thank you. What do you use for cosine?
Adjacent and a hypotenuse.
Adjacent, hypotenuse, and then tangent is
Opposite and adjacent.
opposite and adjacent. Okay, that's the main thing, is that you know what the ratios are. Okay, now like I said, if you're missing one of the sides, you can use your Pythagorean theorem to find the missing side before you can do the ratios. Okay, now when we were waiting for everybody to get logged on today, I was talking with a couple that signed in early about quiz 2 from chapter 10. Okay, quiz 2 over chapter 10 for number 13. If you look on page 483 at example 2, that is what it was talking about, okay? Because a lot of people either just didn't even answer number 13, or I don't know what you did. But anyway, on there, what it's asking is which isometry was performed. Okay, so you have our 4 main choices. You have a reflection, which means it's flipped over. You have a translation, which means it's just slid. You have a rotation, which means it's turned. Or you have a glide reflection, which is a combination of 2 of those. Glide reflection means it is slid and flipped. Okay, Glide is what they use for sliding, translating, okay? And reflection, of course, is it flipped over. So it has those two things together. So what it's doing, if you look at page 483 at example 2, remember we had our isometries listed here, okay? If you look at example 2 up here, you have your original image is the original pre-image is the black triangle right there. And then it has these different things done to it, okay? That's similar to what was that picture that you had for number 13 on quiz 10. Quiz 2 for chapter 10, okay? So you had your original one here. So to get to the green triangle, to go from the black one to the green one, it was a reflection. They just flipped it over, okay? To go from the black triangle to the blue one down here, it is a 90-degree rotation. It just turned it and went to the next quadrant. To go to the little orangey red one up here, from triangle ABC, the original, it was a translation. They just slid it up and over to the right. And then to get to the purple one down here, it's a combination. Because basically, if you look at it, it's like they slid the reflection, the green one. So it's what they call a glide reflection. They flipped it over the y-axis and they slid it down. So those are these 4 terms are the answers that you would use for number 13. You're going to use either translation, rotation, reflection, or glide reflection. Okay, so that's what number 13 on quiz 2 from chapter 10 wanted. So if that's one of them that you needed to correct, or if you hadn't bothered to turn it in yet, then that hopefully will help you get that correct, okay? Now, I was sending out some more emails and stuff yesterday. Some of you still have a bunch of quizzes, tests you owe me, okay? Anything that you still have not sent me, your worksheet on reflections, translations, rotations, I got some of those sent to me yesterday, thank you. Okay. Some of you still had other work that you should have sent me. Okay, remember I'd asked about sending your work for like your prisms, cylinders worksheet and your cones, pyramids worksheet. Okay, I had like 2 or 3 of you actually show me that. So any of that stuff you owe me, please get it sent in. Now remember, for next week, do you have anything on Monday? No. Monday's Memorial Day. Now, there are some of you that you need to get very busy on your FLVS class this weekend because next week's it. And then you're going to fail your history class and then you're not going to have that credit. Okay? So even if you're not planning on coming back here, you still have to have a history credit. So if you don't want to have to take it again, get busy, get it done. Okay? But some of you are way behind on FLVS. So use that time. Now, do I still want all my geometry quizzes and tests some of you owe me? Pedro? Yes. See, he turns his camera off then when I'm talking to him. He knows.
Come on, man.
Yeah, see, see? So make sure I get all that stuff. Now, remember next week, we don't have anything on Monday. Tuesday and Wednesday, I still will see you for review, but that review will not be at 11. It'll be like today. It'll be at 11:15, okay? It's a little bit later because where you have an exam in the morning to give you a little bit of time, you know, a little extra time after exam, or if it took you a little longer on your exam to still where you could have a break before you had to come for review, okay? So they're at 11:15 next Tuesday and Wednesday. On Thursday, you take your exam. Your exam for geometry is at 1 o'clock in the afternoon. All of this is on that schedule that I send as an attachment to everyone Monday. But some of you don't check your messages on My School Works, so you don't know anything about what I'm talking about. But I sent everybody a schedule through My School Works on Monday afternoon. So make sure you have that, okay? So Monday, nothing. You work on stuff on your own. Tuesday, 11:15 review. Wednesday, 11:15 review. Thursday, exam, 1 p.m. Okay? Everybody got that? Okay, so this is your last exam that you will have to finish out the school year. Your exam for geometry will be your last thing. When you're done with your geometry exam Thursday afternoon, then it's over. Okay, this school year is done. So you have 3 more meetings with me. Now, please make sure that you've studied this weekend, though. I think your grammar is what, Tuesday morning? So when y'all have your grammar exam. So study for that. Wednesday, you have an easy day, just kind of reviewing, getting caught up on stuff, doing FLVS. And then Thursday is your exam for me, okay? So everybody knows what's going on. Everybody understands what they still need to work on, hopefully. Check your My School Work messages like every evening, because I'll be sending stuff. I may send you some extra notes or pointers for your exam for next week. So make sure you've got your stuff ready. Don't forget about filling out your notes in your orange folder and sending me pics of those done, because I'm giving you credit for doing those. Okay, so that's an easy grade. Just going through and filling those out, looking at the book. Okay, so don't forget about that. And then study, have a good weekend, get everything done. And I will see you.
Bye. See you.
I didn't say bye yet.
Bye.
Y'all are